This presentation is designed for those of you that have decided to move on from pre-cut materials such as silk or imposter or metallic and want to experiment with all sorts of different type of yarns. In order to do that, though, you do need to understand some basic characteristics of different types of yarns, what they can and cannot do for you when it comes to kumihimo. So let's start from the very basics. There are two general categories of yarns. Either they're natural or they're man-made. When it comes to natural, you're talking about yarns that come out of, they're derived from animals. A good example would be silk, for instance, or wool or cashmere. There are also plant-based yarns that are natural, such as cotton, which comes from a seed, versus linen or rami that come from a plant or a leaf. And then you have a very little bitty category that a lot of people don't think about as a natural product, but it is, and that's mineral. There is a long tradition in many countries, starting with Japan, but also in India, to weave with real gold or real silver. And that's a yarn. The way it's used, it's a yarn, and therefore it should be categorized as such and as a natural product. Man-made materials could either be regenerated from natural products, such as, for instance, rayon or tencel, or they're really totally, completely synthetic and created primarily from petrochemicals. And that's the case of things such as polyester, acetate, nylon, thermoplastics, etc. So let's delve a little bit into how yarns are actually made. You start with fiber, and there is a clear distinction between fiber and yarn. Fiber is the fluff. So when you shear a sheep, for instance, what you get, it's fiber. And that is not ready to be used as a yarn yet. It has to be processed somehow. And there are three different types of methods to process the fiber and make the fiber into a usable yarn. One of the ones that we know probably we're most familiar with, particularly for wool, is called carding. And typically the carding process uses two sets of drums, like the example that you have here in the photograph. And it smooshes fibers together, and then the fibers, the smooshed fibers, are then spun into a yarn. What is interesting about carding is that you can use both short and long fiber, and they're all blended together. The problem with that is that the yarn is not particularly strong, and it tends to be fuzzy, and therefore it's more prone to peeling. That's part of the reason why a lot of kumihimo teachers don't particularly like when students use wool when they're making samples, because it's very fuzzy and it makes it very difficult to read the interlacement. Another technique is called combing. In this case, a device is similar to what you see here. That's for personal use, obviously. Industrial combs are much bigger machines. But the idea is that you're using only long fibers rather than a mix of long and short fibers. And the result is a yarn that is generally more compact, stronger, and less likely to peel. The third method is called continuous. And you see that in two different areas. You see it in silk making, as well as in man-made materials, such as polyester. Both silk and polyester are considered continuous yarns. So in the tradition of silk making, you start with the cocoons, and then you start pulling the yarn out of the cocoons, and then you wind them together, as you see in the process here in this very old vintage photograph. And that is a continuous yarn. There are no breaks in the yarn. It's not plied, it's not tied together, it's continuous. And the process is for the silk is called reeling, because you reel the yarn on that device that you see on the right. Man-made materials such as polyester are also continuous, and we'll talk about that in a little bit. The advantage of a continuous yarn is that there are no breaks in the yarn itself. Therefore, the yarn tends to be much stronger, and it will withstand a lot of wear and tear, as opposed to a yarn that combines the short and long fibers. Once a fiber is transformed into a strand, then two or more strands are plied or twisted together. And the interesting thing about this, and I'm not going to spend a lot of time on it, but the interesting thing about this is that you can choose to twist either on the right direction, which is called S, or from right to left, which is called Z. So either left to right S or right to left Z. Why does that matter? Because it does change the appearance of the yarn. It does change, it does reflect the light differently. So it will make the finished piece look a little bit different depending on whether you're using an S twist or a Z twist. Not only that, if you do over twist, in other words, if you twist it very, very tight, as is the case of crepe yarns, then you can create all sorts of interesting surface effects by combining the two different twists. Not a lot of experimentation has been done in kumihimo using crepe yarns, but it does offer some interesting design possibilities. But you have to be very thoughtful in terms of what yarns you're using, how much twist there is to the yarn, how many ends per bundle you're using, and so on and so forth. I did one time many years ago, and I don't know what happened to my sample, but I did a sample using wool crepe, and I set it up with the regular size bundles, 10, 12 something ends, and not all the ends twisted in the finishing process, so it created a very uneven surface, and that's a function of primarily how many ends per bundle I had and how tightly I was braiding, of course. The interesting thing, and this picture unfortunately is not as clear as I would like to, but the interesting thing is that you can play not only with the direction of the twist, but when you're making a yarn, you can also have even twist or uneven twist. So if you think about it, when you're twisting two or more ends together, two or more threads together, you could apply a consistent tension to the twist, and particularly if the ends, the threads are all the same size, you would have a very even twist. And that's the case of, for instance, the pre-cut silk that we use is a good example of a yarn that has a very even twist. Karakumi silk also has a very even twist. And it's very, very important that that twist be even because it does, as I said earlier, it does affect the look and the appearance of the yarn. But you can also create very interesting textures by having an uneven twist. So for instance, by combining a thick thread with a thin thread, or by applying different pressure to the different threads, and so you get more slubbiness, if you will, in the yarn, and that will create texture. And you'll see that a lot of the spun silk, particularly the kind of spun silk that comes out of Europe, is designed to be just that, to have an uneven twist, to create a surface texture when used. Okay. As I said earlier, longer fibers produce a stronger yarn. So real silk is much stronger than spun silk, for instance. But the additional strength in the yarn can be achieved by applying different fibers together. So that's why you see oftentimes you see blends of, for instance, spun silk and steel, or cotton and polyester, or silk and rayon, and things of that sort. Because if you have a weak yarn, you apply it with a strong yarn, and you're building additional strength in the finished product. So there are some factors that you should consider when you're looking at yarns for kumihimo. First and foremost, you need to think about what it is that you're doing. What is the purpose of the piece? So for instance, if you're thinking about wearable stuff, such as jewelry, for instance, or if you're doing a white piece and you want to do a scarf on the takadai, for instance, or you want to do a belt or whatever, if it is a wearable, you do need to think about absorbency. So for instance, some materials tend to absorb, like wool, it's a good example, tend to absorb more water and therefore sweat than other materials such as polyester. With that in mind, if you think about it, you do a scarf in wool, it tends to, particularly if you wear it a lot, is more likely to stain than if you did a scarf in polyester, as an example. You also need to think about abrasion resistance. That means that if you wear something a lot, there is a friction between your skin and the braid. And if you're using a product that has a combination of long and short fibers, or just short fibers, there is a tendency for that piece to start peeling. And that's the byproduct of abrasion. So the more you wear it, the more it's going to start getting fuzzy and peel. Think about the sweaters that you wear. Oftentimes, if you wear them a lot, particularly in areas like around your elbows and places where you do have a lot of friction, you start seeing peeling. You start seeing all this little fuzz on top of on the surface of the material. That is something that you probably don't want in a jewelry piece. So you got to think about what materials will give you better resistance to abrasion than others. Drapability is also something that it's very important, particularly if you're doing things such as necklaces or scarves or belts and things of that sort. You need to think about how well the finished piece will hang or fall, okay? And some materials do a better job of being drapable than other materials. Elasticity is also something to consider. And that is, it's really a combination of two things. When I think about elasticity, I think about the inherited elasticity of the yarn, such as if you take for instance, a yarn that is being plied with elastic, it tends to stretch while it's under tension from the weight of the tama. But once you release the tension, it goes back to its natural state. And so you could create stretchy headbands, for instance. But there is also another element of elasticity to consider. There are some materials that have a tendency of stretching to the point of breaking if they're under too much tension. And that's the case of plastic yarns like vinyl, for instance. The end result is that you may start with a diameter, a specific diameter at the beginning of your braid. By the time you're done with the braid, the diameter is totally different because the yarns have stretched to the point of no return. So also you need, related to that, you need to think about the strength of the yarn. So if you're working with a very delicate yarn, and some metallics are very delicate, then you probably want to make sure that you combine it with something that is stronger, or you have more ends, so that the mass itself of the bundle makes the yarn stronger. Luster and the size of the individual strands, the individual yarns are also important. So the luster means either you have a very shiny finished braid or you don't, and it all depends on what you're using. The size of the individual yarn is important also in terms of what you're expecting to be able to do with the piece or not. So if you think about thin yarns, such as what it's used for the pre-cut silk, they tend to be more flexible, and they tend to, particularly if you're not beating hard or you're not pulling the thumb hard, you tend to have a very flexible and grippable braid. But if you're working with very thick bundles or very thick yarns and you're beating hard, then the look and the feel of the braid will be totally different. So there is no specific rule. It's just these are things that you need to think about it depending on what is the purpose of your braids. So I want to talk a little bit more, just very quickly, about some specific types of fibers that are available to anyone that do not require you to have relationships with industrial producers. And I think that it may be helpful, maybe a refresher for those of you that are familiar with different fibers, but it's also something that I think you can keep in the back of your mind as you experiment. So let's start with wool. Wool and hair fibers are probably the most common ones that you find all over the place. You find them at Michael's, you find them at Walmart, you find them in fancy knitting shops. They have most of these fibers have a scale construction, meaning that the fiber is not smooth, but it's kind of jagged. And it gives them the ability of felting, unless they're specifically treated not to do that. They vary in length. The fiber itself can be long or short, can be very smooth or very coarse. So you have on the right, you see a picture of one of my pashmina shawls. Pashmina is the undercoat of a specific goat from the Himalayas. And because it's the undercoat, it's much softer than the outer coat. And it produces a very thin, very durable, very soft yarn. And if you have ever touched a real pashmina shawl, you know what I mean. On the other hand, the outer coat, which is not discarded, it's used for other purposes, it's much coarser. And if you think about it, these goats live in the Himalayas, so they need the double coat, and they need the coarseness to protect them from the cold and the environment itself. But that is the outer side of the coat. The inside, the underneath, or the belly in some cases is much, much, much softer. So when you grab a skein or a ball of wool, you got to think about it. Is it soft enough to be used for kumihimo, or is that too coarse? Coarse wool works well if you're doing slings, like if you touch the original slings from the Andes, you know what I mean. They're very, very coarse, because for their purposes they need a very strong wool, and it doesn't matter that it's soft to the touch. But if I'm doing a shawl, I want something that is pretty darn soft. The silk, there are two types of silk. There's the most common one is called bombyx. It comes from the silk moth bombyx. The bombyx silk moth is it's not wild. So there are facilities all over the world where the moths are raised and fed mulberry leaves. And they tend to produce very white, pure white silk. If you look at the picture here, and you look at the little bitty skein on top, you'll see that that's a bombyx silk, and that's from Habu Textiles. I double checked with her to make sure, and yes, indeed it is bombyx. And you see how bright the white is compared to the other ones around it that are Tassa silks. And Tassa silk comes from a variety of different moths. The most common one is Imperia perinea, and they are wild, so they're not raised in captivity, so to speak. And they produce a silk that ranges from ivory to brown. And the skein that you see in the picture on the right is actually a natural yellow. That's the color that it comes in. It's from Laos, and it's much, much brighter than the naturally yellow silk that I have from Japan. And that's why I included it in the picture, because I thought it was incredibly interesting to see how bright the color is. And it's all natural. It depends on the kind of leaves that they eat that will affect the color. The two silks that you see on top, on the left, the brown and the beige, they're also natural colors. They're Tassa silks, but they're spun instead of being reeled. And they are from Abu Textiles. I believe she got those from India. I did not have time to check with her, but I'm pretty sure that's from India. Okay, but you see a very nice, interesting range of colors in the Tassa, which is not present in bombyx. Bombyx, natural bombyx, is white, period. That's it. There is nothing else to it. The first quality silk is derived from reeling cocoons, and it's true both for bombyx as well as Tassa. But there is always waste, and the waste is not thrown away. So the damaged or pierced cocoons or other remnants of silk are used to produce a variety of spun silk. So the silk can either be reeled or spun. A lot of the silk that comes out of Japan is reeled. That's what makes it very, very, very strong. And that's what makes it very easy to use. It will not peel, it will not break easily, and it will allow you to work very lightweight pieces, almost transparent fabrics, for instance, because of the strength of the individual yarn or thread, excuse me. But the spun silk has its merits, it's very interesting to use, has all sorts of different properties. That's where you see a lot of slubbiness in the yarns. It's typically from spun silk. There are all sorts of different types of spun silk. One type is called noil or burette, and is used by using the fuzzy part of the outside and the inside of the cocoon. Then you have a type called chape, which is it's spun primarily from damaged cocoons. And whatever is left over after that is done, you have shantung. And a lot of the shantung that you see here, the three white cones, for instance, is shantung. They're all very slubby. They're designed to provide texture in the yarn itself. Linen. That's probably one of the most common plant-based fibers that it's readily available around the world. The fiber is produced using a process called retting. The fiber needs to be separated from the woody part of the plant, and that's done through decomposition. Once the decomposition has reached a certain level, then the fiber is separated manually or with machines, and the woody portion is not thrown away because it's going to be processed again to make pulp, which is then used to make paper, as an example. So nothing goes to waste. That's an important part to remember, that nothing goes to waste. Typically, you have two types of linen. One is called line, and it's generally longer, smoother, thinner, and it's ideal for garments, bed sheets, lace, bobbin lace, etc. And another type is called tow, and it's generally shorter, coarser, and it's traditionally used for towels, for instance. So the piece that you see on the right, it's a hand-woven piece made out of hand-spun tow linen. And you can actually see the frayed sections, you can actually see how thick that yarn is. Linen, to me, it's a very interesting alternative for kumihimo, particularly if you're using line linen, because it's not likely to peel as much as spun silk could or does. And it just gives you a different look to the braid. Other plant yarns are things like rami, hemp, banana, jute, sisal, etc. All those yarns are processed in a way that is similar to the way you process linen. Basically, you gotta separate the pulp from the fiber from the woody part of the plant. And once you go through that process, then you can either spin the yarn, or as in the case of rami, you actually hand tie the yarns. So the little bitty skein that you see, the little bit of ball that you see there, is my attempt to learn to tie rami fibers into a yarn. Because they're tied, they don't use knots. They kind of twist the two ends together. But because they're tied, there is quite a bit of fragility to that yarn. And so when Japanese weavers weave rami, you will see that they often have a humidifier in the back of the loom to keep the yarn moist. So the moistness in the yarn makes it more pliable, less brittle, less likely to break. But breaks happen all the time when you're weaving rami. It's the nature of the beast, and you have to be extremely patient. So would you have the same issue if you braid with it? Probably not, because again, you're going to use multiple ends. You're going to create bundles. But there is a certain amount of roughness to rami that you don't necessarily have with hemp, for instance, or even linen. So that's something to consider. Cotton is probably one of the fibers that is not used as much as it should in kumihimo, I think. So the piece on the right that you see is a gradient necklace that I designed for lunatic fringe using their mercerized cotton. And it's a gray scale going from black to very, very light pale gray. Mercerized cotton is probably the most appropriate for kumihimo. Mercerization is a process it's a chemical process that makes the cotton stronger, increases its ability to absorb dyes. That's how you get very brilliant colors. Improves the color fastness, meaning that the colors are not going to fade out as much as other type of fibers, and reduces shrinkage. And it's generally more shiny than non-mercerized or unmercerized cotton. So to me, cotton is interesting. It's a cheaper alternative. I would probably take cotton over tencel. I have my own biases against tencel, but it is an interesting material to consider. So let's talk very briefly about man-made yarns. The regenerated cellulose fibers such as rayon or modal or tencel are not considered purely synthetic because they're created from natural materials. So the cellulose is that it's left over from other processes is extracted and reduced to a liquid solution, which is then extruded through devices that have holes that are called spinnerets. And if you Google spinneret, you'll see some very interesting industrial machines. And the process creates a continuous filament that can be used as a single monofilament or grouped together in applied yarn, as are the examples of these tencel. All these tencel yarns that you see in the picture are plied yarns. A lot of you guys use imposter that's made out of rayon. So it is a regenerated cellulose fiber, okay? Modal has become very popular because it's very, very soft and it's very drapable, and sometimes it feels almost like cashmere without the price tag. So you'll see a lot of modal used in garments coming out of primarily Europe. Synthetic fibers are typically made from petrochemicals. So they start as a liquid polymer, which is extruded again through a device called spinneret, similarly to what you would do when making rayon. The continuous filament is very smooth and it's quite strong, and it can be used as a single, as in the case of that blue cone that you see at the bottom page as a single. Or you can actually cut it into sections and make it into a spinnable fiber. But the appearance tends to be a little bit more fuzzy and it's not as strong as a continuous filament. The construction varies quite a bit. And it all depends on the size of the hole or the shape of the hole that it's used in the spinneret to extrude the yarn, and whether the extruded fiber is straight or coiled or crimped. You get all sorts of different textures. And there are basically a number of different nomenclatures, but the most important ones are polyamide or nylon, polyester, and acrylic. So most synthetic yarns have high abrasion resistance and do not peel. Because of the way they're constructed, in other words, they're extruded, you can create permanent shapes to the material. And you do that by applying heat. So you can crimp the fabric, or you can create bubbles like in the example here in the picture. Then you apply heat and those shapes remain, they're permanent. The important thing to remember is that all these yarns, even though they start from petrochemicals, so from petroleum, they have gone through all sorts of different processes. And right now, the impact, the environmental impact of these materials is not as bad as it used to be back in the 70s. And the quality of the yarn and the fabric that you can derive from those yarns is quite different. And oftentimes you will see that, particularly coming from Europe, not so much from China, but coming from Europe, a lot of these yarns are the result of recycling plastics. So there are some fundamental benefits associated with these materials that a lot of people are not necessarily aware of. Metallics are not metal, but they're designed to resemble metal. Typically, you start with a flat film that is that can be encased in aluminum or thin layers of plastic and polyester. Or you can apply it together with laminating yarns that has been dyed or ground up aluminum. So there are different methods to create metallic yarns, but the end result is that they're supposed to look shiny like metal, okay? You have all sorts of different types of metallics. You have what we call slit, which is generally flat. So in the picture that you have there, you'll see the yarn in the center, kind of reddish. That's a slit yarn. It's very flat. You can have plied yarns, and you can create all sorts of different color and texture and reflectiveness through plying. So a good example is the pink yarn on the left. It's plied, it's two yarns plied together. One is transparent and the other one is pink. So you have a lot of iridescence in that yarn that you wouldn't have any other otherwise. Then you have a class of yarns called GIMP. Instead of applying the metallic film is wound around the core. And the core could be visible or not visible. So at the bottom example there that you see that it's kind of looks like spotty, it is a metallic film plied around washi paper. And it's done in a way, not plied, excuse me, wound around the washi paper. And it's done in a way to expose some of the washi paper. Okay, so it's done on purpose to show some of the core through the yarn. Okay, and these type of yarns, again, they're plied around they're wound around the core, and they're called GIMP yarns. And then you start getting into a total different category of yarns called what I call non-traditional materials. And these are yarns that come out of totally different industries that have been produced for the automotive industry, as an example. And they have been integrated in all sorts of innovative fashion designs. But you also have some other interesting yarns that are not necessarily industrial in nature, but they're very interesting blends, such as soy and silk, spider silk and silk, metal and cotton, metal and silk, you name it. And you also have paper. Paper comes out of a very old tradition in Japan. And it is a very interesting material to work with. But when you think about paper, don't think about the sheets of paper that you use to write. Paper yarn is different. It's generated from pulp, and it will withstand water. So you can wash a finished piece that uses paper in it. Okay, it's not going to melt away. The texture, the feel, and the drippability is quite different from traditional yarns. If you think about it, thermoplastics were developed to create fabric that would be used to cover seats in cars or to make floor mats in cars. So drippability is not an issue, but durability is. So that yarn, if you use it in your work, it's gonna look and feel differently than if you were using silk. Okay, so you got to think about what was the original purpose of these materials, and your expectations should really be set based on that. So you cannot expect a braid made out of thermoplastic to behave exactly the same way as a braid made out of silk. Different materials, different effects. And that is it.